students, today we'll study motion and this is the lecture 2 where we will cover two topics. First is the types of motion, another is your scalar and vector quantities, right? Now types of motion, here we will cover all types of motion that you can see in your daily life. So that I have told types of motion and scalar and vector quantities, right? Let's move. So types of motion, here you can see periodic motion. Now this is our earth. It will revolve around this sun, right? But for a particular time, it will take for one revolution. So that is the periodic. That means a particular time, within a particular time, it will complete its one revolution. Again, it will start another revolution, right? Another thing also important, that suppose this is the axis of the earth and this one is your earth. So it will move with respect to this axis. That is the rotation. So rotation and revolution, that these two, that is the periodic in nature. Because with respect to this axis, the earth will rotate within one day. That means it will take 24 hours, right? So these two are the periodic motion. Now, if I can see that I have thrown some ball towards any one of my friend. So here you can see that this will follow curvilinear motion. That means this will follow the curved line. This will follow the curved line. This is the curved line. So you can see that the ball will move from my hand to my friend's hand by following curved line. So that is curvilinear motion. So curvilinear motion. And then oscillatory motion, this wall hanging watch, that is very well known to us. In your childhood also you can see. Nowadays it is not used widely, but in our childhood we have used a lot here. Now this is the pendulum and it will move from this position to the final position, then again it will come back. Again it will come back. So it will move from this position to this, again it will come back and it will take the same time. So this is the oscillatory motion. This is the oscillatory motion, right? Then the circulatory motion. This is very well known to you. You are driving the car or you are cycling. At that time, your tire, that will rotate and with respect to this fixed point. With respect to this fixed point. That is the circulatory motion. Circulatory motion, right? Then translatory motion. Okay, fine. So this is also related to your daily life. Sometimes you are going for morning walk. Here in this picture, I have shown 100-meter race and time has been given 10 minutes. But it might be if you are going for morning walk, then you are moving. So you are walking. At that time, it is translatory motion. If you are participating in your school's sports day, at that time you are participating in race, that is 100-meter race or 200-meter race. So here they are doing this thing. It might be the yellow shirt person. It's you who won the game. So that is the translatory motion. That is the translatory motion. Now, the translational motion, let's define this thing, where one object moves along a path in one of the three dimensions. Any of the three dimensions or one of the three dimensions. Fine. So, this is our y-axis, this is our x-axis, and this is our z-axis, right? Either I will move in this way, or I will move in this way, or I will move in this way. That means I have to follow any one direction of these three directions. That means I have to move along a path. I have to move along a path in any of the three dimensions, right? Then rotational motion. It is the type where an object moves along a circular path about a fixed axis. About a fixed axis. Now, your ceiling fan, it is just with a fixed axis, it will move, and art, it will move. Object in your circular path, that is the tire of your cycle. Tire of your cycle, you can see that this is a fixed point. This is the fixed point. With respect to this point, the tire is rotating. The tire is rotating, right? So these are the rotational motion. That means what? The object moves along a circular path about a fixed axis. About a fixed axis, right? Next is the linear motion. Linear motion, that is actually the translational motion. One type of translational motion where the body moves in a single direction along a single dimension. Then periodic motion, it is the type of motion that repeats itself after certain time interval. So what we have drawn there, some pendulum, and it will be here after certain time. Again, you can see that the pendulum will come back to this position. So from this position to here, suppose this is the position A and this is the position B. You can see that from position A to position B, it will move to and fro, to and fro, to and fro. But for certain time interval, it will maintain a particular time interval. So that is the periodic. That is the periodic motion. Okay. So what is periodic motion? That repeats itself, the motion that repeats itself after certain interval of time. After certain interval of time. Next is the oscillatory motion. You can see everywhere. Sometimes you are playing with the oscillatory motion. So it is the type of motion which is repetitive in nature within a time frame. Within a time frame. Suppose I have one spring here and I am just giving any force. Okay. So I am giving some force. You can see that spring, there will be some vibrations here. So this is the oscillatory motion. This is the oscillatory motion. Okay. Now, whatever I have told, that motion in dimensions, right? Motion in one dimension, motion may be in two dimensions, motion may be in three dimensions. But how? Motion in one dimension means, suppose I have x-axis here, y-axis here, and z-axis here. I am just working along this x-axis. That means my motion one dimension. Now I am running along negative x-axis, right? This is also one dimensional. I am moving upward, or I am just going underground. So that is your one dimension. That means this three dimension, among these three dimensions, you are following only one dimension. It may be in this or in this path, you are following this path, or upward, downward, or positive z direction, negative z direction, but you have to follow only one direction. It is not like that you are following x and y both, only one direction. So one dimension you have to follow. So whenever I am just following straight line, at that time the motion will be one dimension. Here you can see with a very good shoe. This is the initial condition of the person and he has gone to the final position. So he started his journey from xi and he has covered the distance xf minus of xi and he reached here. So but this is in one dimension. So this is the one-dimensional motion. One-dimensional motion. Now the two-dimensional motion. In this picture, you can see that here some shells, or this is also very well known to you. You can see in any fair, and you are sitting here and you are just enjoying this journey, right? So this is the two-dimensional motion. How? Suppose I am throwing one ball and some of my batchmate or friend, he has taken the ball. But what is the ball? It will follow this path, right? So in this path, if I will ask you how much distance it has covered, I will ask you how much distance it has covered, whenever it is at this point, what you will say me? That yes ma'am, along x axis it has covered 4 meter, suppose. Along y axis, that means the height of the ball from the ground, that is 2 meter, right? So that means it has two coordinates, 4 meter and 2 meter. So it is at a height of 2 meter from the ground. Also it is 4 meter away from the initial position. So that is the coordinate of the position, coordinate of the position of the ball. That means what? It is two-dimensional because it has the position in two coordinates, not in one coordinate, right? Now three-dimensional motion is a very interesting picture. You can see that whenever the motion in space you have at that time, whenever the motion in space you have at that time, what? Sorry. At that time, you can see that along the x-axis, y-axis, z-axis, along these three axes, you have the motion. So this is the three-dimensional motion. Three-dimensional motion. Now, Mr. Question, here you can see that first question is the what are the various types of motion? What are the various types of motion? Explain briefly. So what are the types of motion? Translatory motion, your circulatory motion, periodic motion, oscillatory motion, all these things we have described. You have to give the definition as well as always keep in your mind, whenever you are defining the any type of motion, you have to give the example. And I will suggest you always try to give the example from your daily life. Suppose it is your periodic. Okay, remember the wall hanging watch which has the pendulum, right? Suppose it is rotatory motion. You just think about your earth and sun, this, or your earth rotation. Okay, so always try to give the example that is very much related to your daily life. Define the uniform motion and non-uniform motion. Here, uniform motion, that means for a particular span of time, always it will cover, the object will cover the same distance. Non-uniform motion, that means the object may vary the distance or the length, okay, for equal span of time. Next, the name the type or types of the motion being performed. Smoke particle from chimney. Fine. So this is our chimney. Suppose this is our chimney and smoke particle is flowing away. So smoke particle, it has no fixed direction. Hence, it is random motion. So the motion of this particle or this smoke, that is also does not repeat itself. So that is non-periodic. That means it is random motion and non-periodic. Sometimes you can see that, yes, some smokes are there. Sometimes you can see that the smoke quantity is less, right? So I cannot define in this way that it has some particular type of motion. So very random motion it has. Sometimes the smoke is there, particles are there. So some random motions in this Here you can see particles are very random. Particles are very random, right? Next question. Art around the sun. Fine. Very good question. Art around the sun. What is this? Circular motion? Yes. Because the fixed point is the sun. Rotatory motion? Yes. Because the art will rotate around the sun. Periodic motion? Definitely. Because the art will rotate around the sun for a particular time. For one revolution, it will take particular period. That means it is periodic motion, right? So art around the sun that has circular motion, rotatory motion, periodic motion. Okay, three types of motions are present. Then flying insects. Okay, flying insects. Sometimes here, sometimes here, sometimes here. Sometimes it will bite. It will bite, Mr. Question Uncle. Fine. How I can define that? Yes, the insect is moving towards x-axis or towards y-axis or towards z-axis. I cannot define. So it is a random or irregular motion because the insect may be at the head of uncle or maybe at this feet or anywhere. So it is irregular motion. So because it can change any direction, its direction it can change at any instant of time. Some MCQs are there, very easy MCQs are there. Here, the motion of an object in which the object travels in a straight line and its velocity remains constant along that line. And it covers, this line is very important, equal distance in equal time of interval of time. That means the object is moving in a line and straight line and it will cover equal distance in equal interval of time. So what type of motion this one? Obviously the uniform motion. Next question. Yes, Mr. Uncle, question uncle. Next question. If a body is involved in rectilinear motion and the motion is consistent, rectilinear motion, and motion is consistent, then the acceleration of the body must be. Now, first thing, the rectilinear motion. Rectilinear motion, that means you are walking in a straight line and linearly you are walking. So, acceleration will be 0. That means for a particular span of time, I am just moving particular distance. If I am moving for 1 second, I am moving 2 meter, then next 1 second I will move 2 meter, like that. So this is the rectilinear motion. So it has the acceleration 0 because there is no change in the distance for any interval of time. Then movement of the blades of ceiling fan. Okay, all of you just watch your ceiling fan. So you can see that it is the uniform motion. And your ceiling fan, it has some fixed point and it will move whenever your regulator, provided you are not changing the regulator position, 4, it may be 5 or whatever. So suppose you are keeping at 5, the ceiling fan will move with a particular motion. So that is the uniform motion. The motion of the train. Fine. Train means what? The total journey. First, it will move in this path. Then the train will be here. Some junction is there. Some bifurcation of this path. Okay. So it will follow this direction. Okay. Suppose my train is moving in this direction. That means what? At the time of this curvature, it may be it has just covered a different distance with respect to this. So that is the non-uniform motion. Distance time graph for non-uniform motion shows a curved line. Okay, because non-uniform motion means there should be for uniform motion it was like this. For curved motion it was like this. right? So that means it is a curved line. Now, scalar quantity. So, motion in all dimensions we have studied. Different types of motion we have studied. But scalar quantity and vector quantity we will study because it is very relevant to the dimensional motion, right? So scalar quantity, that is defined as the physical quantity that has only magnitude, not direction. Suppose I have some potato having the mass of 5 kg. Okay, so here the mass, it has some magnitude, but it does not have any direction. So that means this is scalar quantity. The temperature of my room is 27 degree centigrade. So that is our temperature. That's why I can say that this has only the magnitude, no direction is possible. So I can say that yes, this is the scalar quantity. Now addition and subtraction of scalar quantity very easy. Only algebraically you just add or subtract. Algebraically, suppose I have 5 kgs potatoes, again I have bought some 7 kgs, then it will be 12 kg. If 6 seconds, after 3 seconds, how much? Total time span is 9 seconds. If I have covered 50 meter, then again I am coming back 20 meter, then actually I have covered 30 meter. So that means what we are doing, just algebraically we are doing the addition and subtraction process. So this is applicable for scalar quantity. This is applicable for scalar quantity. So some examples of the scalar quantity: mass, speed, distance, time, volume, 1 liter of water, 2 liter of water. So I am not saying that yes, this water bottle that is in this direction or that direction, right? So that is the volume of the water. Density, temperature, all these are some examples of the scalar quantities. Next is the vector quantity. For vector quantity, it has the magnitude as well as it has the direction. So that is the vector quantity. Suppose I am moving towards north or I am moving towards east, right? So at that time you have the distance. I have just covered 5 kilometer towards north, 5 kilometer towards east. That means what? Here you are saying that yes, I have moved towards east and 5 kilometer. Then I have moved 2 kilometer towards north. Then again I have moved towards south some 2 kilometer, right? That means what? In every point you are saying that the magnitude, that is the 5 kilometer you are moving, but in a particular direction, towards east, towards north, towards south. So the vector quantity, that is defined as the physical quantity that has both the directions and also the magnitude, right? So this is the vector quantity. And vector quantity we will represent, suppose this is the point A, tail of the vector, this is the B. So we will represent AB length in this way, or we can represent AB in this way. That is the vector quantity. One hat should be there, right? This is the vector because it has an additional parameter, that is towards east, north, south, towards X direction, Y direction or Z direction. So that's why one hat I have just given, right? So this is the notation of the vector. So this vector notation, now if you have some vector quantity at that time, you can denote with respect to V and some notation should be there, arrow mark should be there, right? If you have the velocity, then you have to give in this way. Sometimes it may be this is not the length AB or CD or write that. It may be some quantity. So here you can see that B, above that you have to put one arrow. So some examples of the vector quantity: linear momentum, acceleration, displacement, momentum, angular velocity, force, electric field, polarization. So here, just for suppose point A and B, I am moving from this point to this point, or I can move from A point to B point following this path. So this is called distance. This is called distance. This is called distance. So this is called distance. That is scalar quantity. But from initial position to final position, whatever the shortest path you are taking, that is the displacement. That is the displacement, right? So displacement is a vector because you are moving particular direction. Angular velocity, that is a vector quantity. Force, suppose I have some box and I have to give the force here to drag the box towards this position. So the force, whatever you are applying, it will be in this direction. That means it has some magnitude as well as it has some direction, right? I can give the force right downward. Okay, so it will move forward or not, I don't know. But the force, it will move forward or not, I don't know. But the force, whatever you have given, that force you have given downward. Okay. So here, this picture, scalar quantity and vector quantity, this illustrates. Now here you can see that speed is a scalar quantity because you are moving 50 km per hour. Your speed of the car may be, if you are moving highway and you are just 120 km per hour, or you are racing 200 km per hour, right? So at that time it is scalar. Now the weight, that is the vector quantity, because whenever this apple is here, at that time it will give you, yes, it is suppose 100 gram. It is suppose 100 gram, but there is some gravitational force also here. Gravitational force also here, right? So that's why it has the magnitude as well as it has some direction. So that's why weight is the vector quantity. But remember one thing, mass is that scalar quantity. Weight is the vector quantity. Now the difference between scalars and vectors. First, you have to give the definition. A physical quantity with both the magnitude and direction. Scalar, a physical quantity with only magnitude. Representation, a number direction using unit cap or arrow at the top of the unit. I have told you, suppose V, I have to give arrow, or I have to gift one cap. So at this top, I have to give this symbol. But here, only the magnitude. There is no symbol here. If it is your mass, then M. If it is your temperature, you can write down T or time for T. Then symbol, quantity symbol is in bold and arrow sign above. Here only the quantity symbol. Direction, yes, vector has the direction. Scalar quantity, no, it does not have any direction. Example, velocity, acceleration, mass and temperature. Okay, so these are the differences between scalars and vectors. So vector addition and subtraction, it is not so much easy as the scalar addition and subtraction. In scalar, what you have done, 5 kg potato, 7 kg potato, and you have said me, yes ma'am, 12 kg potatoes, right? But no, here it is not possible. Here addition subtraction of the vector quantities, it will follow some triangular rule or trapezium. Here you can see that one vector is here, which tail and head. Then again from this head, B vector, tail will be connected and the head is here. So the tail of A vector and the tail of A vector and the head of B vector you have to connect. So you can get A plus B. A plus B. Now if for the both vector, this point, that is the both the tail will be connected here. At that time B minus A is the vector here, or A minus B here the vector. Okay, here you can see this direction. This is B minus A, and here you can see that the direction is in this way. So it is A minus B. Okay, so this addition subtraction of the vector quantity we cannot do using the only simple algebraical method. We have to use some different methods. Here also the trapezium rule that I have told you. Suppose you have some u vector here and some v vector here. So what will be the u plus v? This is the diagonal of this trapezium, right? So this is the vector addition. Vector subtraction also, here you can see that vector subtraction means addition of two vectors. One vector is positive and another vector is negative. I can say the subtraction of vector, that one vector is positive, another vector is negative. Just I will add these two, so I can get A minus B. That is the vector subtraction. So again, uncle question. Okay, come. Here some quantities has been written and we have to specify which type of quantity. Scalar 20 degrees Celsius, 5 meter north. If it will say only 5 meter, then it is scalar, but it has mentioned that north, so it is vector. 5 meter scalar, that I have told you. 256 bytes, that is scalar. 30 meter second per second is vector. 400 calories scalar. What is the vector and scalar quantity in physics? A scalar quantity is defined as the physical quantity that has only magnitude. On the other hand, a vector quantity is defined as the physical quantity which has both the magnitude and the direction. How are vector and scalar different? Obviously, one has direction, another does not have any direction. How are vectors and scalar quantities alike? Both have the dimension, that is the magnitude. Both are measurable. What are the examples of scalar? So many examples I have given. From that, you just pick any two and you just give it. What are the examples of vector? Lot of examples I have given. You just take any one. Displacement, angular velocity. So you can do. Now, example of scalar quantity. There are 4 quantities has been mentioned here. Among these, electrical charge. Because force, that means it has some direction. Force, it has some direction. Weight, moment, all these 3, they have direction. But here electric charge, no direction. Vector quantity, among these 4, weight. Temperature, yes, it is a scalar quantity because it has only the magnitude, no direction. 15 degree Celsius. Oh, so cool. 15 degree. Only 15 degrees Celsius. So this is scalar quantity. 4000 calories. Scalar quantity. Types of vector. There are 10 types of vectors. Zero vector, unit vector, position vector, co-initial vector, like-unlike vector, coplanar vector, collinear vector, equal vector, displacement vector, negative vector. Okay, so there are 10 types of vectors here, and these 10 types of vector we will discuss Okay, so there are 10 types of vectors, and we'll study this in the next lecture. And till then, bye bye and thank you.